Let's look at the match design and analysis more in detail. So true or false? A match design controls for confounders. And actually this depends. So does it mean that if you would never match in a randomized trial since confounding has already been taken care of? And the answer is actually you may match because you match or stratify in a randomized trial. Because remember, the confounding is not completely taken care of, not necessarily, right? Because we are using chance, and so there might still be potential for some confounding. Does it mean that once you match in your design, you do not need to worry about the confounder in the analysis? That is actually not true. You actually do have to worry about how to account for now in analysis that is reflects a match design. True or false? A matched analysis is equal to a stratified analysis. And if it's true, does it mean that you could use the CMH option, Cochrane-Mentor-Hansel option in PROC-FRIC to do either a matched analysis or a stratified analysis? And the answer is actually true. And you can see that matching is just a type of stratification, and you can use a stratified analysis to account for matching. So there are two critical steps when deciding whether to do a matched study or not. The first is you need to really carefully determine whether you do need matching. Keep in mind that the more variables you match on, the more finely you match on. For example, you create pairs. You're going to put a lot of effort, energy, and time into matching. At some point, it may become counterproductive. One of my first studies before I became an epidemiologist, I thought that matching was the only way I could control for confounding. And so I developed a case control study and then matched on everything. And you will see later in what problems this can cause. But certainly I spent quite a lot of time finding the right person to match on just about everything. It took a lot longer to finish the study than if I had not matched. And now looking back, I should have not matched. Secondly, during the analysis, you need to recognize the data are matched. Matching may happen just naturally, or it may be happening because you did it. In any case, anytime you receive a data set, always ask about the design. It is critical to recognize any data independence or dependence. Data independence is the #1 assumption for most of the tests that you already know about. The chi-square, the t-test, the ANOVA, logistic regression. If you have a pair design, then this assumption is no longer valid. And so before you start any analysis, always ask, are these data independent? And just because you didn't match, it doesn't mean that nature agrees with your design. You could have hidden natural matching. And also keep in mind that pairing is not the only matching possible. One of the earlier mistakes I made was when I was working on gene therapy using rats, and I was injecting both the right and left salivary glands. And it never occurred to me that these were actually matched. Fortunately, I kept track of which gland belonged to which rat, and when I was asked to provide the information, I had it. But I almost lost like 3 years of my life working on gene therapy and not realizing that I was actually conducting a match design.